So on this next example, I have the square root of x over x squared minus 3x. All right, so we have a couple options. We have a couple things here. We have a radical in the numerator. So my numerator is not for all real numbers. It's restricted. So that means I have the square root of x. That means x has to be greater than or equal to 0. Well, that's kind of cool. I don't really have to do any math there, right? That's already done for me. So that's not too bad. I kind of like that. And then for my denominator, this is only true for values that make, or I'm sorry, this is true for all values except for the numbers that make this equal to 0. So we got to go and set it equal to 0. You will be expected to know how to factor something simple like this. Again, what we're basically asking ourselves is what two numbers multiply to give you -4, add to give you a -3. You think about that, you carry along, you say, oh, that can be x minus 4 times x plus 1 equals 0. That is the factored form. Factored trinomials broken down into a product of two binomials. And now you have the product of two binomials equal to 0. So now you can apply the zero product property. And then you can say x equals 4 and x equals -1. But again, what does it mean, x equals 4, x equals -1? Those means those numbers are not in the domain, right? So let's think about this. All numbers have to be greater than 0, but they can't be 4 or they can't be -1. So for this one, I'm actually going to graph the domain to kind of make sense of it. So I'm at 0. 0 is good. All numbers greater than 0. Cool. But can it equal 4? No. So at 4, I'm going to put an open circle. Do I really, and again, I don't really care about -1 here because that's not even greater than 0. Then to write my domain, just write it in segments. What's the domain from 0 to 4? Well, 0 is included. 4 is not included. And then I'm going to connect it with 4 to infinity. OK? All right, last example.